All right, guys, here's a quick little example of an angle measure problem. All right, again, we're being given a description of a geometric event here, but we can't see it yet. If we can't see it, this becomes much more difficult if I can't see and manipulate and see what's kind of going on. So we got to get a picture of this. I need to get a point Z, which is inside of angle MRP. So let's start off. Let's make an angle. An angle is formed from two rays starting at the same point. We need to name that angle MRP. This middle letter has to be the vertex of the angle and will be on one of the points, P on one of the other rays, and I need point Z somewhere inside there. This is going to allow for a third ray to exist inside this angle. So now I actually have the big angle we started with, and it's been broken into two pieces that aren't necessarily equal. I wasn't told that ray RZ was a angle bisector, so it hasn't necessarily been cut in half. That can happen. But let's put this information on here. MRZ. MRZ is this angle right here that goes from here to here. And I'm going to put its value directly inside that angle so I can really see what's kind of going on. ZRP. ZRP. That's the angle that goes from here to here. That is 4x plus 8 degrees. And MRP is the entire angle. So somehow I got to make some sort of the entire angle is 180 minus 3x. So the trick here is, man, I got to be able to see the equation that exists here. All right, there's no way that this 32 degrees has to equal 4x plus 8. But the angle addition postulate, would say this. So this postulate means this has got to be some sort of a basic idea, something that nobody's going to ask you to prove. Well, if I take this one small angle MRZ, if I add the rest of that other small angle ZRP, well, we should get the entire angle, which is angle MRP. If we can see that the large angle is the composition of the two smaller ones, then I can make an equation that says that 32 degrees, if I add 4x plus 8 to it, that better equal 180 minus 3x. And again, the left side and the right side of the equation don't look a lot alike, but using our algebra skills, we can derive a value of x, make a value of x come to us that would make this equation true. So first step, we would want to look on either side of the equation and see if we could combine some like terms and make this problem a little bit easier than what it is right now. I can combine 32 and 8, which gives me 4x plus 40, and nothing to combine on the right side. I'd want to get all the x's on one side. We have more x's on the left side, so let's get rid of the ones on the right by using an opposite operation. If I had negative 3x's, if I add 3x's, those are going to cancel. That's what I want. If I add 3x to the left side, because I have to balance my equation, now I have 7 x's on the left and just 180 on the other side. Now I got two numbers next to x there that I want to start moving to the other side of the equation. If I use an opposite operation, I see addition, so I'm going to use subtraction. If I had 40, take away 40, that gets me down to 0. That makes it go away. Now I only have 7x on the left side, and I got 140 on the right. If I divide both sides by 7, now I know that x happens to be 20. Now realize, none of the angles up here measures 20 degrees. I would have to take 20 and plug it in to see what each angle actually measured. If I put 20 in here, 4 times 20, that's 80 plus 8 would be 88 degrees. If I put 20 up here, 180 minus 60 leaves me with 120 degrees. So these are not easy problems, but if you give yourself a visual and write all over that diagram and try and write an equation, big part is make sure you're writing an equation you believe in. You can do that. There's nothing you can't do.